Oh, hey, didn't see you there. Welcome back to another math video from the Mathnasium. Today, you're going to go over the rest of the rules for graphing any quadratic that you would like of the form ax squared plus bx plus c. Strap yourselves in. Today's going to be a wild ride. Make sure you have some graph paper, pencil, maybe a notebook, something to jot down these rules. Graph paper would be helpful. Alrighty then, let's go ahead and jump right in. But first, let's do a quick refresher. What is the purpose of A and C in this equation? What function do they serve? Well, it turns out B does not change the effect of A and C. It operates independently of A and C. What does A do? A stretches the parabola up, it compresses the parabola down, makes it wider, and it can flip the fraction if we want to. C is always our Y-intercept, and it's going to kind of shift the shift our quadratic function up and down. So we take a look at here. I have on Desmos, I have the parent function, and I have the red graph set to the parent function as well. You can see as I increase the value of A, it's stretching. Some people think it looks like it's pinching inwards. It's actually not. It's being lifted up, so it's giving the illusion of being pinched inwards. Stretching up, and then when it's in between 0 and 1, it's wider than the parent function, and it's getting compressed or kind of squished down. Such a heavy... Let me take that weight off your shoulders, parabola. Okay, and then you get down to the negatives, and there it goes. It's wide between, when it's a decimal and negative, it's opening down. And then a big negative number is narrow. It's being stretched, okay, so on and so forth. We can see what happens. Let's go to, like, say, a value of 2. A is equal to 2. Great. What does C do? C does not change the shape. The shape remains the same. It is just moving it up and down. Great. So what in the heck does B do? Well, we're going to get there. First, I'd like to do a quick review graph of these so we can kind of see that method, and I'm going to kind of tack on a little bit in addition to what we did last time. So let's take a look at one where B is 0, and we'll just do a quick refresher, make sure we're all good here. Feel free to skip past this if you remember this from last time. So last time I said you graph the parent function, and then you manipulate the parent function with A. This would be a stretch. It's opening up, and then you'll take all those points and shift them down 3. Well, the other thing that you can do is you kind of start at 3 if you want, in some cases. Start at the vertex. So let me make this big, and we'll come back to that Desmos here in just a minute. You can start down here at -3, because you know it's going to get stretched, and then we're going to shift down. 3 is going to be my vertex. So we can start here if you want. Now, we know that it has the same shape as the parent function, except it's been stretched up by a factor of 4. So normally with the parent function, 0 squared is 0, 1 squared is 1, 2 squared is 4. It looks like this. So when I go, normally if this had the same shape as the parent function, if it was x squared minus 3, I'd go over 1 up 1, but I'm not going to go over 1 up 1. I'm going to go over 1, and I'm going to go up 4 times the amount. So I'm going to go over 1, and normally I would go up 1. I'm going to go up 1, 2, 3, 4. Okay, and then I can reflect that over the y-axis. Okay, normally with the parent function, when I go over 2, 2 squared is 4, go over 2, up 4, I'm going to go up 4 times that amount, which would be up 16. Oh my goodness, it's so high up. So I can kind of put some dots here. Yikes, that's a lot. 11, 12, 13, 14, 15, 16. All right, there we go. Moving up, and then we can connect these way up. Ho, ho, ho. Let's go fly a kite. Look at that. Up to the highest height. There it goes, our parabola. And those are not the smoothest curves, but I did my best. Now that time was a little different. We started down here and we worked our way. We knew the shape. That's what we're looking for. Do you know the y-intercept? Bingo, it's right there. Do you know how this stretch works? yeah, we're stretching everything upward by a factor of 4. Okay, so what the heck does b do when I add a b? Now you may be saying, oh, well, this changes the shape. This shifts up and down, so the only parabolas that seem to be missing are the ones that are shifted to the left and to the right, and you would be correct. And so that is what b does. b shifts our parabola to the left and the right, but it doesn't do so in a manner that you may think. It doesn't shift to the left and to the right in the way that you may think. It's a little more complicated than that. So it looks to me, so some solid characteristics that were noticed from class were, people said that it looks like the parabola is moving in the shape of a parabola, which it is. If you follow the vertex, it's kind of moving in that shape. The other thing you could say is you can say that the y-intercept never changes. So when I move it, the y-intercept remains 0 as I am changing b, which is pretty awesome. So you can see that kind of beautifully as I'm sliding, it stays 0. Now if I change the y-intercept to say like -5, for example, we can go ahead and hide this purple one. If I change it to -5 and I continue sliding b, you know, it's going to be sliding it from the left to the right and moving it all around. So that's exactly what b does. It moves our graph from the left to the right. Okay? It helps shift our graph, but it's really shifting the axis of symmetry, left or right. But it's not doing so how you would think. So if you make b 6, for example, it doesn't mean that it is going to go to the left 6 or to the right 6. It just means, well, we're going to give you the equation here in just a second. So it's helps shift the axis of symmetry to the left and to the right. And now just a quick recollection, the axis of symmetry is that line about which the two sides of the parabola are symmetric, and the vertex, our peak of our peak, or the very bottom of the trough of our parabola, is our vertex, and it always lies on the axis of symmetry. Okay, so that's a great thing to know here. So b helps us shift the axis of symmetry. What have I just done? Just broke the game, folks. Get out of here. Yikes. Try that one more time. Shifts our axis of symmetry left and right. So here, if you're given an equation, you know, with any a or any b, this is the formula that we use to find the equation for the axis of symmetry. Now here's a quick reminder. That if you have, for example, the line x equals 3, if you have a line that says x equals, that is always a vertical line. X equals is a vertical line in the standard coordinate plane. And the line x equals 3 is a vertical line that travels through the x-axis at 3. And really what it is it's a collection of all the points that have the x value 3. So if you end up getting something like this, our axis of symmetry is always going to be a vertical line at this point. So that's the equation for the axis of symmetry. Now if a parabola is on that line, if this is the axis of symmetry, then the vertex of that parabola has to be on that line. So whether it's opening up or opening down or what have you. Okay? If you have a parabola that is symmetric about this line, the vertex of that parabola has to be on the line, which means the x value of that vertex, so I should be more clear, this is the line x equals 3, this dashed line here, the x-coordinate of that vertex has to be the same. So it means that our x-coordinate of the vertex is going to be -b over 2a, comma, something, and I'll tell you what that something here is in just a minute. write that in blue. Okay, great. So it's going to be a vertical line. So let's go ahead and run through this process. Let's do a couple practice problems with our axis of symmetry, calculating the axis of symmetry. I'm going to do the first one. You can see how it's done, and then you can try on your own. All right, so for example, here we would do, let's calculate the axis of symmetry. Let's do, it's x equals, it's the line x equals negative b over 2a. So we're going to plug in those values. That will be negative 2 divided by 2 times negative 3, which is negative 2 over negative 6, which simplifies to 1/3. Both are negative, and a negative divided by a negative is a positive number. So our axis of symmetry is the equation x equals 1/3. What would that look like on our graph? If this is 1, 2, 1/3 be coming through right here. Vertical line at 1/3. Pretty exciting. Now I'm going to mix this up a smidge. This next one, I have it as positive. I am going to change that to a negative. Whoa. Oh no. Why is that happening? Control Shift. There we go. All right, perfect. I'm going to change it to a negative here, just because I'm going to try to throw a curveball at you guys here. All right. You guys try this one on your own. Come back to me when you're done. So I changed this to a minus sign. Here we go. X equals negative b over 2a. We start with our equation. We're going to plug this in. We're going to end up with negative. B is negative 4, so it's negative negative 4. Opposite of negative 4 divided by 2 times a is 1. We end up with 4 divided by 2, which is 2. Fantastic. That is exciting. Okay, great. So this is the line x equals 2 as our axis of symmetry. Hopefully that's starting to make sense. So now let's work through graphing an entire one of these from start to finish. I'm going to go through the whole process, write down the steps if you need to, if you think it's going to help you. Okay, step 1 will be in red. Step 1, find the axis of symmetry and the vertex. Ooh, okay, right off the bat, I can look at this, and what we know from last time is, all right, this is a narrow quadratic. It's twice as narrow, or it's been stretched up by a factor of 2, and we know it has a y-intercept of 3. So from last time, everything that I learned in the last lesson still holds true. That's a-1. Okay, our axis of symmetry is negative b over 2a. So let's go ahead and plug those values in. Very similar to what I've been doing. That's going to be negative 4 divided by 2 times 2, which is negative 4 divided by 4, which is negative 1. So my axis of symmetry is here. My parabola is symmetric about this line. Exciting. I can hardly contain myself. Now, the vertex. I know the vertex is somewhere on here. So how do we get the vertex? How do we figure out where that is? Now, there are a couple ways to do it. I'm just going to do probably the most common way. The most common way is to take this value of negative 1. We know it has the x value negative 1, and we're going to plug it into our equation to retrieve our y value. So we can say y equals 2 times negative 1 squared plus 4 times negative 1 minus 3, which will give us y equals negative 1 squared is 1. Following order of operations, I'll do my exponents first. Now I'm going to go through and do my multiplication. 2 plus negative 4, or 2 minus 4 minus 3. You get a y value of negative 5. Cool. It's got the vertex of negative 1, negative 5. That is so exciting. That. There's my vertex. Sweet. Okay. Now, you can actually be done right now. If you want to be done graphing this right now, then use what you learned yesterday. So this is not the official steps. I'm going to kind of teach you a shortcut here first really quickly. So you could be done right now if you wanted to. And you could say, hey, this is the shaped just like the parent function, except it's been stretched up by a factor of 2. And normally with the parent function, I go over 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, so on. I'm going to go up, though, double the values that I normally would from the vertex. So when I go over 1, instead of going up 1, I'm going to go up 2, right? Instead of going up 4, I'm going to go up 8. Be right here. Instead of going up 9, I'm going to go up 18. Oh, wait, that's off my graph. So you can use this technique and then reflect the points to graph our parabola. That's perfectly acceptable if you want to do it that way. Or you can follow the steps that I'm going to teach right now, which also works. So it says find the intercept, the y-intercept. Well, the y-intercept is given to us in the equation. It's the point 0, -3. Hey, look at that. Isn't that the one that I just plotted? Yeah, that's my y-intercept. Fantastic. Okay, what else can you do? We need to find one other point. So we went 1 away from the axis of symmetry. Let's now go 2 away from the axis of symmetry and see what that looks like. We'll say x equals 1. Let's plug that in. When x equals 1, what's the value of y? I'm sitting at the edge of my seat here. So anxious to know what this value is. Y equals 1 squared is 2 times 1 plus 4 times 1 minus 3. 2 plus 4 minus 3 equals 3. Hey, look at that. Wasn't that the wasn't that the point that I got earlier? Yes, it was. Step 3, reflect those points across the axis of symmetry. Symmetry, look at that. Axis of symmetry. Done. Bingo. And now we can connect the dots with this absolutely stunning parabola. And I had a great start to that. Absolutely, I said absolutely stunning parabola. All right, that looks pretty good. All right, I'm not going to try and replicate that. So, I know I'm cheating. I know you guys can't do this in your notes, but you also don't have to write on this atrocious tablet. Oh, that is the best one I've ever done. Pause the game. Video over. Video over. This is perfect. Okay, so we reflected the points across the axis of symmetry. We are now good to go. We got this beautiful graph going on. Fantastic graph. Beautiful quadratic. Okay, so I'm going to do this process basically 3 more times with some different examples. Watch it until you think you got it, and then we can go from there. All right, here we go. Let's do it again. Do it 3 more times. I'm going to keep the colors the same, except for maybe on the last one. Step 1, axis of symmetry. Negative b over 2a equals negative 6 goes in, 2. A is negative 1. So negative 6 over negative 2, which will give us a negative divided by a negative is a positive 3. So we have a positive 3 as our axis of symmetry. We know that our vertex is somewhere on this line. Somewhere on here is our vertex. So we know our vertex is 3 comma something. So to figure out what that is, I'm going to plug it in to the x position. Great. All right, super. Plug it into the old x position. And the question in here, this is probably the most common mistake that's going to be made on this assignment, is right here. Negative 3 squared. What is that? Well, I'll tell you what. negative 3 squared and negative 3 squared with the negative on the inside are not the same. One of them is negative and one of them is positive. Okay, if the negative's included, then it is part of the multiplication, so it's negative 3 times negative 3. This one is positive 9. This one here is the opposite of 3 squared, which is negative 9. So what we're left with up here is negative 9 plus 18 minus 5. It's 14, which is a positive 4, so that means our vertex is the point 3, 4. Bingo. Got our vertex locked on target. Now, you could be done. Right here is the shortcut. You can jump ship and skip the other 2 steps if you recognize the a value and the shape. We've got the vertex and we know the shape, so we're basically done. The shape is, this is shaped just like the parent function but flipped. So that would mean you could go over 1, down 1, reflect, over 2, down 4, reflect, over 3, down 9. That's not right. Reflect. Okay, and you could be done. So that's the shortcut. If you recognize the a value and you understand that method, you're good to go. Okay, if not, you are forced to do the other way, which is actually not that bad either. What's the y-intercept? Well, the y-intercept is given to us. It's the point 0, negative 5. We can pull that from right here. That's our y-intercept. So we can plot that, which was one of the points that I graphed, right? Over 1, down 1, over 3, down 9, puts us at negative 5. Okay, and one other point. So I'm currently 3 away from the axis of symmetry. If I go to 4 away, I'm probably going to be off my graph. So I'm going to go back a little bit closer. I can choose either 2 or 1. Doesn't really matter. I'll do x equals 1. We're going to plug that in. We get y equals negative 1 squared plus 6 times 1 minus 5, which is negative 1 plus 6 minus 5, or we get 0. This is the point when x is equal to 1, y is equal to 0. Okay, we have one other point, and we have our y-intercept. So now we can reflect those points across our axis of symmetry. Oh, it's beautiful. Absolutely stunning, Charles. And this is where I lose my mind. It's nice knowing everybody here. There we go. Can I do 2 in a row? I got greedy, but it's all right. That's our quadratic in all of its glory. Okay. In red, axis of symmetry. Feel free to pause right now and try this one on your own if you want. Negative b over 2a. Let's do this. Negative 6, 2 over negative 3. We end up with negative 6 divided by negative 6, which is 1. There's our axis of symmetry. X equals 1. That's a lot of fun. Now we can find the vertex. The vertex of our parabola is y equals negative 3. Now we're going to take 1, the value from before, we're going to plug it in. X squared plus 6 times 1 plus 1. And let's go ahead and simplify. 1 squared is 1, so we have negative 3 times 1, which is negative 3, plus 6 plus 1, which gives us a y value of 7, 4 again. So we end up with 1, 4. Okay, so we've got our vertex, and now this is where you can be done if you recognize what's going on. What's going on is this is the parent function, but flipped and stretched by a factor of 3. So it's upside down. Normally with the parent function, I go over 1, up 1, so I'm going to go over 1, but I'm not going to go up. I'm going to go down from the vertex 3 times as much as I would from the parent function, which would be 3. Reflect the point. I can go over 2. Normally when I go over 2, I go up 4, but now I'm going to go down 3 times that much, that amount. So 3 times 4 is 12. I'm pretty 14, so that's going to put me down at -8. And I can reflect and be done. That's it. If you don't recognize that, then you can do it the hard way, which is what I'm going to do. How do we do it this way? Okay, we got our y-intercept. Our y-intercept is going to be, it's given to us right here, 0, 1. Oh wait, that's the point that I had earlier. Okay, cool. Reflect. Okay, next point. We need at least one other point, so we'll do, let's see here. We could do x equals, so these are both 1 away, so we need to do x equals -1 or x equals 3. We will do x equals 3. We do y equals -3. When x equals 3, y equals -3 squared plus 6 times 3 plus 1. So we end up with here, y equals 3 squared is 9, 9 times 3. So that will be -3 times 9 plus 18 plus 1, which is y equals -27 plus 19, which is going to give us a y value of -8. -8. Hey, look at that. When x equals 3, our y value is -8, and we can reflect that. Hey, look, that's exactly what we got in the previous one. This is fun. I'm having so much fun. Hey, that wasn't half bad. Okay. There we go. All right, next one. It's the last one, so again, I'm just going to do a bunch of examples, so feel free to try if you want. X equals -b over 2a. The opposite of -4 divided by 2 times -1, which gives us +4 over -2, which gives us the x value, -2. So our axis of symmetry is x equals -2. Okay, so we then have the vertex. -2, comma, well, we got to figure it out. So we got to plug this in. We're going to do y equals the opposite of -2 squared, which is really like having a -1 right there, minus 4 times -2 minus 6. All right, let's do this thing. We end up with -2 squared is 4, so it's -4 plus 8 minus 6. So that is going to be -2 if I'm not mistaken. So -2 is our vertex. And then if you know the shape, it's shaped just like the parent function, so I'll just run through that really fast. Over 1, down 1, reflect, except it's opening down because it's negative. Over 2, down 4, reflect. Hey, look, that's our y-intercept. What do you know? Over, whatever, over 3, down 9. But let's do it the other way as well. Okay, step 2 in blue. Our y-intercept is -6, so we can plot that and reflect. I'm kind of doing step 3 simultaneously. Great. We have that done, and now we have things that are 2 away. Why not choose something 1 away? Like x equals -1, we can plug that into our equation. Y equals -1 squared minus 4 times -1 minus 6, which is minus -1 squared is 1, plus 4 minus 6, y equals -1. Let's see. 7. I think it's -3. Yep. So -1, -3. Reflect that point. That's it. We are done. Hope this process made sense to y'all. Oh, yes. Oh, my goodness. Whoa. Oh, let me get a picture of that. Look at that. I'm taking hundreds of pictures every second, but just had to Uncle Bob that one and take a quick photo. All right, guys. Hope you like this process. Hope it makes sense. And look at the beautiful things that we can create. Oh, it's so much fun. All right, that's it. Hope you guys, if you have any questions, shoot me an email. See you next time. Thanks for watching. Mathnasium. Slagle out.